Okay, we take another integral. We've got the integral of sine x times sine 2x over 1 plus sine cubed x dx. Okay, I thought this was kind of interesting having everything in terms of sine. The one thing I want to fix before I really do anything is I want to get everything with a single angle. I don't really like this sine 2x here. So let's just use the double angle formula on this, and we can write this as 2 sine x cos x. And then I'll rewrite the integral. First, we'll bring a 2 out front, somewhere over here. And then I can multiply this sine times this sine. We're going to have sine squared x in the numerator times cosine x dx. And then over this stuff, 1 plus sine cubed x. And the thing we have now is we've got sine still in a couple places, but we've got the derivative of sine right here, cosine x dx. So let me do a u substitution on this. I'm just going to do u equal to sine of x. du is going to be just cosine x dx. Go ahead and substitute on this one. We're going to end up with, this becomes u squared. This over here is our du. So we have u squared times du over 1 plus u cubed. And it was funny because the first time I did this, I was like stuck at this point. And sometimes it's just the way you look at it and you don't really see what's going on. But if I just do something, if I actually multiply in a 3 here, and we'll divide by 3 up front, so we're just multiplying by 1. Then we have the derivative set up for another substitution on this. So what I'm going to do is we'll use another variable. We'll call this t for the whole denominator. I'll say t equals 1 plus u cubed dt. Take a derivative, we get 3 u squared du. So go ahead with another substitution. Now we have 2/3 up front. Everything cleans up. This is our dt, so we have dt over t. Go ahead and integrate this. We're going to have 2/3. This becomes natural log absolute value of t. Now we just need to back substitute, but let me consolidate because we have to back substitute twice. So if t is 1 plus u cubed, let's plug in our u value and we can write t as 1 plus sine cubed of x. And so let's just back substitute it right here. And so for my solution of this, we're going to have just 2/3 natural log absolute value 1 plus sine cubed of x, add a plus c, and that's it. And so when on the solution, you can kind of see we did 2 substitutions. You could just consolidate this into one. We could have just initially done t equal to this. And then even without, you kind of maybe have to mess with the trig a little bit, but the derivative of this is actually basically this with, a constant. Okay, there you have it. Thought it was a pretty interesting integral. I actually got this one from BlackPenRedPen. He did it a little differently. I think he probably did it the more direct way, and I did it with some extra steps. So I was able to find a slightly more inefficient method. Anyway, that's it for today. Thanks everyone for watching. Have a good day.